Alright, come on. I might have to refresh the page. Okay, here we go. Alright, it's only a minute late. Okay, I guess we're good to go. I need that. Where was I? Where was I last time? Okay, I've got a few to-dos. Right, I think I can start here. Excuse me. I did go back and re-added all the missing things in the parser. So I think we should be good to go. Okay, then maybe starting on the compiler. Say test source/code. Right, okay. Although it did pass, the code is pretty shite. Or maybe not. Well, let's see. Okay, the smallest compiler. Now that we have a toolbox called code, we can start working on the compiler. Since we want a system that works from end to end as soon as possible, and not a system that can only be turned on once it's feature complete, our goal in this section is to build the smallest possible compiler. I could only do one thing for now, produce 2 op constant instructions that later cause the VM to correctly load integers 1 and 2 onto the stack. In order to achieve that, this minimal compiler has to do the following: traverse the AST we pass in, find the integer literal nodes, evaluate them by turning them into integer objects, add the objects to the constant pool, and finally emit op constant. Right. Instructions that reference the constants in set pool. Sounds good. Perfect. Kinda. Let's start by defining compiler and its interface in a new compiler package. Package compiler. Got the AST, code, and object. So the compiler has instructions. Instructions, nothing but slice of something. And constants is a slice of object. Right. Yep. Make a new compiler. Compile, does nothing at the moment. Bytecode. Turns pointer to a bytecode. And what is bytecode? It's okay, it's just the same thing. Both are internal fields and will later be modified by the compile method. Instructions will hold the generated bytecode and constants. Right, this is the constant pool. But I bet the thing that code bytecode does blah 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 blah. Bytecode is what will pass to the VM and make assertions about in our compiler tests. Okay. Pass bytecode to the VM. Speaking of which, the compile method is empty, and we're now going to write our first compiler test to tell us what it should do. Okay. I wonder if a compiler is a good use case for TDD. 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 Got package compiler. Expected constants. Expected instructions. Why can't this be a slice of object? Or is object an interface? I think so. Let me check. Yeah. Oh, just realized. Got boolean and null. Go to register some of my types. Oh, like wrong tab. Compiler test case. Okay, what if we test in? So let me try and understand. We get a new we got a new compiler. As of now, it takes nothing. What's the output of? Okay. Guess we can call make. It's a bit warm now. To get the Don't return instructions. It's just that's a good point. Okay, it's the same. Slice or byte. Okay. Okay. Just checking. Okay, so I'm guessing no, because bytecode happens after compile. Oh, interesting. You pass it an AST node. Because this is the program. Okay, guess we'll just have to read through it. Expected constants. What was constants again? Slice of object. Expected instructions. Code.make. Interesting stuff. That's not what we returned though. Okay, yeah. Got it. Right. Okay, I guess that makes sense. Because we know how make behaves, we can use this in the test. Okay, maybe. On compiler test. Okay, it's below. Right, you go through each case, get a new compiler, compile program. Where did he get program from? Right, okay, it's the input. Parsed input. What is parse? Guess, okay, here, yeah. Well, I guessed that bit. Right, okay. compile bytecode is compiler.bytecode. This should match our input. Okay. Expected instructions bytecode dot instructions. Right, you go through each and then they should be the same. Test constants, same idea. Okay. Test instructions. I think this is just a string comparison. But it's not a const, it's a slicer byte. Okay. Okay, yeah. Concat instructions. Right. Why is it doing... So is this a rune or a byte? Guess byte. Concat instructions. What was instructions again? A slice of instructions. I'm not sure why. Yeah. Actual is quote dot instructions or singular. Right, because is it running it in a for loop? No, it isn't. These are all the instructions. Yeah, I don't understand this. Not sure. Because... Is it because we get... The instruction we get contains all the instructions? Maybe. Gotta look up. What was instructions again? Oh, got it here. Hang on. Where's my... I totally forgot the instruction. Slight oversight. Oh, I even missed definition. Oh, okay. Instructions are just slice a byte. That's probably why. I was like, nah, don't need it. Guess I do have definition. No. Maybe I just decided against it. What do I return? Oh no, I do have definition here. What am I saying? Okay, instruction is just a slice of byte. Just makes it more confusing when you say instructions. I wonder if he created the type instructions to ensure it was output of the compiler. Maybe. Don't understand the reason. Why you need this type. Why didn't we define it here as slice of byte? Because why didn't we define it here as a slice of byte? Because it's far more handy to pass around and work with slice of byte and treat it implicitly as an instruction than to encode this definition in Go's type system. We'll see soon enough how often we're going to use slice of byte and how cumbersome type assertions and typecasting from and to an instruction type would be there. Right, I'm just gonna find out first. I'm gonna leave it as slice of byte. And we'll come to it later. Cross that bridge when we get to it. Right, okay. So, if I understand, the first thing we need the compiler to be able to do is okay, so if I understand correctly, the compiler needs to separate out all the operands and create the instructions. Create the instructions that the virtual machine can then take and execute. That seems quite apt. I'm not sure if I understand the need for not here, like this one trips me up. What is actual? Is it a single instruction? Should be here. So the compiler returns a single instruction, a single slice of byte. Why would it do that? Oh yeah, okay. So it's just a series of operands and opcodes, of which are the operators. Right. Right, okay. So that's what the compiler would output. And this is just the test case. I think it's easier. Okay, that makes sense. Yeah. Okay. I guess that makes sense. I probably wouldn't be able to do this TDD. So I have no idea what I'm expecting. Maybe. Okay. I think you get all of that. Right. Main part is the uncompiler test. Revolves around two fields of the bytecode the compiler produced. Okay. There are only two fields on the bytecode. For that we have the test instructions helper function. Right. Okay, well he did explain it here. We need to concat instructions because the expected instructions field in compiler test case is not just a slice of byte, but a slice of slices of bytes. Yeah. Oh yeah, yeah. That's because we can use code.make to generate the expected instructions, which produces a slice of byte. Yeah, flatten it. Yeah. Expected actual. Don't think I have any of these tests written. Yep. Yeah. Because they can be... Oh, I suppose the way I... Where's my object? How would I make this comparison? Oh yeah, I can cast it to one of these. Yeah, easy. Don't need to do any of these. That's all there is to test integer arithmetic. Establish how we'll write the compiler. Got nothing. Right. Because it's 16-bit. Oh no, yeah. It should be, I think, better to go back. Yeah, okay. So each number is 16-bit. The opcode is opconstant, which is in enum, starting at 0. And then this is the first operand, and this is the second operand. Okay. That makes sense. Actually, that makes a lot more sense. So this is what we need to produce. What's bad though is the output. I think it's okay. Well, I would have thought if it's an unreadable gibberish, but before working on the compiler, what was I doing? I was working on the embedded stuff, and all you got to see was hex. Now they don't scare me anymore. Well, nice. I like that. But it's not helpful. Compile method, we're going to invest our. Okay. I guess, I mean, this would be quite easy to do. Can have a method on instructions. Yes, that's what he's gonna do. Yeah, here. Okay. Probably won't be creating an instruction type just yet. First thing I need is compiler. That's it. Guess I'll need standard. Import standard. So what do we need to do? If I pass 1 plus 2, the compiler needs to right now, I think all that is doing is adding it to the stack. So it's up constant int. This will be the output of the compiler. Hang on a sec. I just realized something. In the assertion here, there's only one opcode. Shouldn't there be two because he used make? Where's make? Yeah, yeah. Okay, so there will be a single op constant. Opcode. Code. Right. So when he concats the instruction, guessing it takes out, where is it? And out. That is confusing. Shouldn't there be four? Where is it? I think I might have read 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. How big is the opcode? Oh, it's just a byte. Okay, that makes sense. So this is the first opcode, and this is the number. This is the second opcode, and this is the second pointer. Okay, that makes sense. Okay. So it should be really, hang on. I'll keep the object. Don't need the st, don't need the parser. Yeah, so it'll be op constant in op constant and the second int. Interesting. We need compiler is struct. It's got instructions which are slice of u8. Yeah, we'll leave it as it is. And then constants, which are, I need to import. No, yeah. Object import object dot zig. It's going to be object dot object, if I'm correct. Yep. It's gonna have a compile method. It would take the output of the parser. What is the output of the parser? AST. Okay, it's just gonna be node. Does it just need statements? AST is import sick st dot node would return doesn't when writing it out like that, kind of confusing. Okay, I'm not sure what it should return yet. Excuse me. And there was also a bytecode method that returned something. Not sure what is the point of this yet. So the compile method takes okay, hang on. I think it might return. It makes sense to return bytecode here. Instead of excuse me. So what is a bytecode? Not sure either. Not sure either. Guess these are just types. Test compiler. It's a lot harder when you don't fully understand what's going on. Which is part of the process. I need will be an input, will be 1 plus 2. I need a parser. Parser.sig. Also need the lexer. Lexer.sig. Guess I need an allocator. Hang on, I think I'm jumping ahead. Should probably construct the test. Const tests is a struct. Would take input, which will be a slice of const u8, expected constants be a slice of yep, object dot object. Yep. And then expected instruction is going to be slice of bytes. There's only one input though, and I guess one test for now. Yep, dot input will be 1 plus 2. Expected constants does Zig have any type? Is that not a type? Can't have slice of any. It's okay with any. Okay, there is no mention of it. As for now, I can just make it. Gotta check object type. Is it the int i64? Can change that later. Expected constants is equal to, and I always forget, slice. Right. I think it's going to be 1 and 2. Dot expected instructions going to be code dot sig. Code dot make needs an opcode. Code dot op constant, it's capital O. Small op constant, small c. Oh, sorry, code dot. Okay, that makes sense. And then what's the second argument? Make slice of const 60. Okay. And then I need 1. What's this now? Expected field. Oh, sorry. Should be equals. And this should be 2. Kinda looks right. We gotta go through these tests. This is painfully slow. Guess as I expected it to be. Okay, so for each test, guess we'll need the index. Test t. Okay, so what's going to happen is on each input, I need to call the compile method, and I need to check if the instructions and the constants match. Okay, seems easy enough. Okay, for the compiler, I would need, guess I can use the same testing. Yeah. Dot allocator. Const lexer is lexer dot new or dot, what does it do? Damn, it's only been a couple of days. Can't remember how the lexer works. Token, where's the output? Let me check the parser. Okay, I just use 1, 2, 3, 4, 5, 6. Yeah. Yeah, I even forgot that I'm using the arena allocator. Go down. And input is going to be test.input. Parser.new program is, yeah. There's a fucking spider on my mic. But I think it's a spider. Okay, and what is the output of, and is program a node? It isn't. All right, because you would go through each statement. Okay. Oh damn. No, I think it should be fine. So I can assert is const set testing dot assert program dot len should be equal to test dot expected. No. Well, I guess we can't. Well, it's already tested in the parser, so I guess makes it redundant as well. I'm gonna go with that. So for the output of each program statement, I gotta call the compiler and then assert the output. Hang on, what was the output again? I need, where's my parser? It's a parser error or ast.program. Okay, I think I get the idea. So you go program dot statements. Or we just pick the first one because we know there's only one. Set program dot len dot statements dot len is equal to 1. And statement is program dot statements of 0. Got is, I guess we need a compiler too. Const compiler is new. New, and it would take statement. Got is, what is got? Compiler dot compile. Then I can define new is, what is new? Takes a program, let's say statements. No. I could make it easier. Program, which is ast.program, and then returns compiler. So don't we need to store the program somewhere? Well, I suppose we do. Question is where? The compile method takes a single statement. Let me check the book. Can it take nothing? Interesting. So you only pass it the node or the statement when you call compile. Okay. Yeah, I mean, that's just a lot of confusion everywhere. I mean, it's just me. It's nobody's fault. So the compile method only compiles, and you got to call bytecode to get the actual bytecode. Yeah, because you don't want to return the compiler. I mean, I could even skip this step and just go compiler.instructions if I didn't want to have bytecode type. And then that should be okay. Okay, so that means this will take nothing. And this returns nothing for now. Return. Excuse me. Bytecode for now. Just gonna remove. Create const compiler error. Just set error. Check the parser error. It's small e. For now, there's no error in there. Yeah. Compiler error. Okay, so when we call new, I might need to take an allocator because I'm thinking to use an array list for the compiler. Yeah. Guess that would be easier. How do you use array list? Does the compiler need? No, I think just a new method. We'll take allocator mem is standard dot mem dot allocator, then instructions are going to be standard dot array list where's the init. Type, what's the type? It's going to be u8 dot init allocator. Can it add a? No. That's the instructions, and then constants going to be of type object dot object. Then I can return. Guess these need to be variables. Turn compiler dot instructions equals. Now should it be items or it returns self? What is self? Yeah, because if I pass in instructions dot items, let me check the documentation. Standard array list. Init. That is, the self is an array list itself. Okay, I think I got it. Instructions, constants. Okay, I think I will create type. Oh, sorry, not yeah, const bytecode instructions. I think I just realized how this could be useful. Object dot object. Right, and this, I want to know what the type is. Return struct itself is this. sometime t type. So the type we passed is u8 for instructions. I know it's not a u8 because you can add items to it. A contiguous growable list of arbitrarily aligned items in memory. This is a wrapper around array of t values aligned to alignment byte addresses. If the specified alignment is null, initialized with init. Hang on, I could check my parser. Array list. Right, here I think it was simpler because I could append the statements immediately. Right, so what I'm gonna do instead, says it returns type, but I'm not sure. So let's say if I pass call array list on a u8, I can't do u8 dot append. Let's see what happens if I say this is instructions. And then constants equals constants. No. Do I need a semicolon here? Oh. Okay, I think I'll figure this out later when the compiler errors. But for now, new takes nothing. I don't think I need this. Don't need both of these. And then I can void. Oh no, void actually. Is null a valid error? I don't think so. Let's return null underscore equals input. Okay. And to get bytecode, make it need compiler. This will be the same self compiler, nothing else. We'll return bytecode. Return bytecode dot instruction multiple, single, multiple. What was that? Yeah. Instructions will be c dot instructions dot items. Self. Constants. A constants dot items. That should add as well at some point. Yeah, I'll fix it when it adds. Right, okay. Now got the program. On statements equals program. Statements. Allocator. Yep. C.compile returns nothing. Try C.compile. Cool. C.bytecode. Okay. That took a while. I guess now, let me center this. Now what we need to do is check if got dot instructions and got dot constants at expected. Okay, so what I can do is create methods, helpers for both, just like in the book. Try, test, constants. We will take statements is a slice of statement. Which I don't think qualifies as a node. Ah, okay, but program does. Alright. So I don't need that. c.compile program. Okay, brilliant. Test constants. I'm out of coffee. And test instructions. Okay. Sorry. Func test constants. Will return void for now. Then we need instructions. Okay. So this one we need got expected will be slice of no, we'll just take slice of u8 bytes, and then got will also be slice of the fuck. Oops. Slice of byte. And this will return an error. Right. For x got, let's go through got. And then we need the index. Instruction, and then I. If can do yeah. Testing dot expect equal. I think it's small e. Expect equal. Expected and actual. Expected. What's expected? Expected of I, comma, instruction. Is that it? I guess so. Then I can do the same here. Expected is gonna be slice of object dot object, and then no. Okay, actually expect can take any type. And I guess I can also I would have to cast these to one of the three. So I guess it should be fine. This will be any type, and then got is any type. No. This will be slice of fuck's sakes. Can it be slice of any type? I don't think so. Slice of any type. Yeah. I didn't think so. Guess for constants, I'll take a different approach. Well, I'll test it later. Got dot instructions, and then t dot expected instructions. Guess I don't need I. And this comma. I guess. Oh, I can remove this now. And what else is there to do? Yeah, I've still got to check constants. Hang on. How did he check constants again? Test constants. I guess Go does have slice of any. As oh yes, I gotta do this too. Let me add it to do. Cat expected instructions. Yeah. That's what I thought. Okay. I guess could just check it here. But the problem is right now the constants can. Oh no, it's fine. Got the constants. And yeah, I also need the index. What I'm gonna do is const guess I expect this to be an integer. object dot integer equals constant dot integer. Testing dot expect equal int dot object integer dot value and sorry, that's the one I got, and expected constants of I. I think that's a typo. Constants. Sorry, test out expected constants. Okay. Guess that kind of works for now. Okay, hang on. Gotta. Yeah, I gotta do it here so that I can pass slice of U8. Do I want to use an array list? I know how long. Do I? No, I don't. Concatenated instructions is going to be u8.init for test.expected instructions instruction concatenated instruction dot end instruction. INSTR. Okay, returns nothing but Canada. So now instead of expected instructions, I can do concatenated instruction dot items. Okay, it's not pretty, but I guess, well, let me try and run it. Zig test source slash compiler. Gotta be at least 10 errors. It's my estimate. It's just one. Oh, yep. Const. Where's my test? 34. Going to be an array of struct. Okay. Now there's going to be 10. Okay. But definitely make needs to be public. Okay, these are like just small errors. Oh, sorry. Up. Expected slice of const that I found something else. Right. Make. Hang on, const use 64. That's not good, is it? Yeah, because 64-bit number, to be fair, it can be signed. Should even be in 64. Right, okay. Okay, there's a couple of errors. Slice of const, and that one's a slice of const u8. Yeah, because it's null terminated. Interesting. Right. Where's the instructions? No. Make. What did he accept? Yeah, it's an int. Oh, I guess. Can I just. Where's make? Oh, wrong file. Yeah, I guess what I can do is does that work? Expected slice of. Yeah. Hang on. I don't know why, but that always trips me up. The slices thing. Alternative initialization using result location. It's a const. Maybe, oh, well, I can make it a const. Oops. Where did it go? That's my test. Yeah, I guess. It's fine. It should work. Can do the same here. Constituate. It's gonna bite me in the back. All right. Okay. No. That's that might be a different problem. Okay, back to the documentation. Slices. Known at runtime 0 and array.len. What about multi-dimensional? I mean, it should be the same, really. Quick check parser. I think I've done it a few times here, but I can never seem to remember. Test. Where are my tests? Yeah. Slice of const u8. I mean, that one's easy. Yeah, it's just const. What about this one? Nah. Const u8s are easy. Are there any slice of... Nah. Okay, let me read the error again. I'm expecting a slice of const u8, but I'm getting pointed to a const array. Not array, sorry. I'm getting a const slice of slice. I don't know if this is correct. Okay. Okay, you're getting somewhere. So compiler, this is going to be standard dot array list. What's the error again? Expected type slice of u8 found. Array list aligned u8 null. What would be... Yeah, I mean, I knew that would fail. I want to know what the type would be. That sounds a bit... Array list unaligned. Array list. Okay, otherwise returns a struct. That's what I want to know, what this struct is. Would this be the type? Or is that an interface that can... Okay, let me check. Array list sig. Yeah, what I need to know is, what is this type? Data structures such as blah 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 blah. Okay, hang on. Maybe. Just maybe. What is there an interface or type for that? I'd like to know what is the type of instructions. Really? Okay. Thanks, Cloud. That was correct. So the object expected AST dot node found AST dot program. Yeah. I knew that'd be a problem. Maybe I could just make it program for now. Expected union type found. Expected one argument found 0. Yep. Init. Yes. Yeah, here we go. Allocator. Okay, that's one. Had this quite a few times. This needs to be variable. Expected type U8, but found slice of U8. Really? Oh yeah, this should be a slice of const U8. No, just slice of U8. Append instruction. No, actually it should just be a U8. Why is... Oh yes, it is a slice of U8. Guess I need to concatenate that too. What am I doing? Okay. So all I need is a slice of U8 at the end. So right now, expected instructions. Guess I gotta go through each byte. Or it's not confusing at all. Integer is now marked up. That one I can fix. Yeah, it should be small e. And there's a typo. Expect. And this can error. What the fuck? Why did the test pass? I have no compiler. That's not worrying at all. Fuck. What am I testing again? Constant dot Am I actually testing? I don't have 14 tests. What's going on? Okay. I guess that's happening. What the fuck? The only thing I can think of is... No, I thought I declared the test wrong. I have a feeling it's not running the tests. Or I'm checking the wrong things. Expected, got... What am I? Test instructions. Got dot instructions. What is got? Compiler dot bytecode. Yeah, should be fucking empty. Dot debug. Debug. Print. Dot. Unless I accidentally. Oops. Printed. So not printed. Fix the compiler. Or implemented, should I say. What's that now? Okay, got dot instructions. Yeah, should be fucking empty. Unless no. Debug the print. Catted instruction dot items. I have a feeling that's empty. No, it's not. Is it X for hex? I mean, it looks wrong as hell. At least there's something there. Okay, you know what? I'll leave that as a problem for future me. Fix this test. Check input X values. They look totally wrong. Then, yeah, I guess I can start off there tomorrow. The fuck? Where is that even coming from? Hang on. How can there be E in hex? Hang on. Format. Guess here. Format specifiers. It's capital. Oh no, there can be. That should be 0. Fuck. Unless... Okay, I think I made a mistake here too. This test might be wrong. Print and check output. Yeah, I thought it was a bit fishy that I got things right first try. I should have trusted my instincts. Check test for code.make. I don't think it's correct. Okay. And set up compiler. Okay, I think it's not bad. I didn't expect it to work today anyways. You know. Well, yeah. Yeah. I guess I'll have to recheck the make method and then check the compiler. I don't think it's a big deal. I'll be able to figure it out tomorrow. Probably a silly mistake somewhere. Usually is. Alright, I'm gonna call it a day there. I'm glad I streamed for 2 hours today. It's been consecutive short streams. I do prefer the longer ones. You get more done. Alright, thank you for hanging out and hope you have a good day. I shall see you tomorrow. See ya.